In this section, we're going to be solving a few log equation questions. All of them have been taken from past papers. So let's see how this goes. So here you have log base 10 of 2x plus 1 is equal to twice log of x plus 1 minus 1. There are a couple of ways to do this. I'm going to show you the different types as we go along. In this case, what I want you to notice is that of the three terms in this equation, two of them are logs, and the last one, which is minus 1, is not a log. So in this case, what we could do is gather like terms, so gather logs. So I'm going to write that as log base 10 2x plus 1, and 2 log x plus 1 on the other side is negative 2 log x plus 1 is equal to minus 1. Now we're going to use a log law or property to combine these two logs. So remember here, when you have 2 log x plus 1, you can write it as log of x plus 1 the whole squared. So that's what we're going to do here first. Remember, all the bases are 10. So log base 10 2x plus 1 minus, instead of 2 log x plus 1, I'm going to write it as log base 10 of x plus 1 the whole square is equal to minus 1. Now I'm going to combine the two logs using the property log of m minus log of n can be written as a single log m by n. So combining these two, I get log base 10 2x plus 1 over x plus 1 the whole squared is equal to minus 1. Okay, so now I have a log equation with a log on one side and a constant on the other. I'm going to use another property of logs, which is if you have a log of x to the base m is equal to n, I can write this as, I'm going to convert this to an exponential equation. So it's going to be log of, m to the power of n is equal to x. These two are the same equation in different forms. So here m is 10 to the power of minus 1 is equal to 2x plus 1 over x plus 1 the whole squared. So now we have, we can rewrite this and solve it. So 1 by 10 is equal to 2x plus 1 over x plus 1 the whole squared. Now it's just algebra. So cross multiply, you get x plus 1 the whole squared is equal to 10 times 2x plus 1. This will give me a quadratic. So x squared plus 1 plus 2x is equal to 20x plus 10. Gathering the like terms and simplifying, x squared minus 18x minus 9 is equal to 0. Now I can just put it into my calculator. I'm going to put 1 minus 18 and minus 9 into the quadratic function on my calculator, and that gives me x is equal to 9 plus 3 root 10, and x is equal to 9 minus 3 root 10. Right, now I just want to write down the decimal values for these. So this would be minus 0.487, and this would be 18.487. The last step would be to confirm that these two values of x are valid in our original equation. So we have to keep in mind that log of a negative number is not valid, and your calculator will throw up a math error. So just checking if negative 0.487 works in this equation. So here it would be negative 0.487 plus 1. That's positive. And here it would be 2 into negative 0.487 plus 1. I'm just going to tell you the value of that. That is positive. So both are positive values. We can keep both of these. Both of these are the solution to that equation. Here's a similar equation that we need to solve. So it's similar in the sense that some of the terms are log terms and one of them is not. So 2 is a constant, it is not a log term. So as we did in the previous question, we're going to combine the logs. So I'm going to write them together. Log base 10 of x minus 4 plus log base 10 of x is equal to 2. And then we're going to combine the two logs using the multiplication rule. Multiplication rule goes like this. If you have two logs which are added and to the same base, you can write it as a single log m into n. So that's the rule we're going to use here. So log x minus 4 into x, all of it base 10, is equal to 2. So we have a single log on one side and constant on the other side. In order to get the x value out of the log, you have to convert it to an exponential equation. So how do we convert a log equation into an exponential equation? Once again, if it looks like this, to convert it, the same base x to the power n gives me m. This is the conversion of a log equation to an exponential equation. And that's what I'm going to do here. Base of 10 from here to the power 2 from here is equal to x minus 4 into x. So this is going to end up as 100 is equal to x squared minus 4x. This is a quadratic. I'm going to neaten it up. And then I'm going to plug these values into my calculator. So the first value that I'm putting in is 1, minus 4, and minus 100. I get x is equal to 2 plus 2 root 26. In decimals, that is 12.198. And the second value of x that I'm getting is 2 minus 2 root 26. And if I write down the exponential value, I mean, no, sorry, the decimal value, that would be minus 8.198. Right. So what we need to do now is check if these x values work in the original equation. Now we have to keep in mind that you can't have log of a negative number. So if I use this value of x, which is negative 8.198, and I put it in here, I would end up with log of minus 8.198, which will give me a math error on my calculator. So I'm going to discard that value and keep the other one. So I'm going to discard this, and the only solution is 2 plus 2 root 26. The next log equation that we are going to solve looks like this. ln 2x minus 3 is equal to twice ln x minus ln x minus 1. Now, remember when we have ln, ln stands for natural log. And though the base is not written in the equation, natural log is understood to have a base of e. E is something you can find on your calculator. It is attached to the alpha key. Okay, it is a constant. You treat it just like you would treat a base of 10 or 2 or any other constant value. Right. So this equation differs from the previous two in that all the terms are log terms. So what we're going to do is just combine the logs on each side of the equation. So to do that, on the right hand side, the first thing I want to do is instead of 2 log x, I'm going to take the 2 inside the log. So when you take the 2 inside the log, it becomes log x squared. Okay, this is one of the properties. So I'm going to write it as log x squared minus log x minus 1. Left side remains as 2x minus 3 log. Right, now these are two logs that are subtracted. So using the division rule, if two logs are subtracted, you can replace it with a single log x squared over x minus 1. Left hand side remains log of 2x minus 3. Now, the beauty of this is that if you have two logs, log A is equal to log B. So a single log on either side of the equation, and they are both equal to each other. If log A is equal to log B, then A must be equal to B. So we have log 2x minus 3 is equal to log x squared over x minus 1. This implies that 2x minus 3 is equal to x squared over x minus 1. Now I'm just going to simplify it by cross multiplication. So I have 2x minus 3 into x minus 1 is equal to x squared. Expanding that, 2x squared minus 2x minus 3x plus 3 is equal to x squared. Simplifying that, gathering like terms, I get x squared minus 5x plus 3 is equal to 0, which is my quadratic. Putting the values in, I get x is equal to 5 plus root 13 by 2. The decimal value of that is 4.30, and I get x is equal to 5 minus root 13 by 2, the decimal value of which is 0.697. Okay, so now I have to cross check with the original equation, and ensure that none of the log values is negative. Okay, so if I put 4.3 into this, 2 into 4.3 minus 3 will definitely give me a positive number, so that's valid. Log of 4.3, I will get a value, and log of 4.3 minus 1 is positive, so that is also fine. I'm going to consider 0.697. 2 times 0.697 minus 3 is what I want to check. So putting that in, 2 into 0.697 minus 3. This gives me a negative value. 2 into 0.697 minus 3 is a negative value, and therefore we can discard this because you cannot have a log of a negative number. And so our answer is x is equal to 5 plus root 13 by 2. This is the exact form. They may ask you to give the answer to 2 decimal places or 3 significant figures. Just follow the instructions. Right, so here's a question taken from the 2024 Feb-March series, paper number 32. You'll notice that it looks slightly different from the questions we've been doing so far. The positive numbers p and q are such that log of p by q is equal to a and log of q squared p is equal to b. Express log p to the power of 7q in terms of a and b. Okay, so let's start with what they're asking us to find. Log p to the power of 7q. Right, so this can be written as log. We can split it up. So these are two multiplied terms in a single log. So we can split it up into log p to the power of 7 plus log q. This is the multiplication rule in reverse. And then log p to the power of 7 can be written as 7 log p. That's another property of logs. So if we can somehow find log of p and log of q, we should be able to express log p to the power of 7q in terms of a and b. Okay, so I'm going to leave this for the time being. We're going to figure out how to find log p and log q. Let's take the first equation given to us. Log p by q is equal to a. We are going to use the division rule or the division property, which says that if a single log has two divided terms, we can write it as log of p minus log of q is equal to a. Okay, I'm just going to write that, put that down as equation 1. The second equation given to us is log of q squared p is equal to b. This is the multiplication rule, so we can split it up into log of q squared plus log of p is equal to b. And the q squared can be written as 2 log q plus log p is equal to b. So this is my second equation. Now I'm going to write my second equation here. So, and I'm going to stack them correctly. So log p plus 2 log q is equal to b. This is my second equation rewritten so that they stack up neatly. Right, so you'll notice that this is just simultaneous equations. And since there's an unknown a and b, I won't be putting it into my calculator. I'm going to do it manually. So what we could do is just subtract the two equations by changing the sign of the lower one. So log p minus log p is 0. Minus log q minus 2 log q is minus 3 log q is equal to, and this is a minus b. So I have log q a minus b by minus 3. I've expressed log q in terms of a and b. I'm going to do the same with log p. So equation 1 says that log p minus log q is equal to a. So log p minus log q we now know is a minus b by 3. I'm going to simplify that to find the value of log p. So that is a plus a minus b by negative 3. So I can just take an LCM, simplify, or do in reverse actually. I'm going to simplify it first. So this negative sign, I'm putting it here, a minus b by 3. And then I'm going to take an LCM of 3 and I'll get 3a minus a plus b. If I simplify that, I get 2a plus b by 3 is log of. So I've expressed both log of p and log of q in terms of a and b. The question says express log p to the power of 7q in terms of a and b. So we know that log p to the power of 7 into q is 7 times log p here. 7 times log p plus log q. 7 times log p plus log q. So that is 7 into 2a plus b by 3. And log q, I'm going to write it as minus a minus b by 3. This, when simplified, becomes 14a plus 7b minus a plus b over 3. And that is 14a minus a is 13a plus 8b by 3. This is the value of log of p to the power of 7q. This question is taken from the 2023 Feb-March series, question paper number 32. It is given that x is equal to log 2y minus 3 minus log y plus 4. Here we are using ln, which is the natural log. The natural log means that the base must be e. That's the unsaid message there. Okay, the question asks us to express y in terms of x. So basically we need to simplify this and make y the subject. Okay, so x is equal to ln of 2y minus 3 minus ln of y plus 4. Now whenever a variable such as x or y is within a log and you want to get it out, what we need to do is convert it to an exponential equation. But before we do that, we will be combining both the logs. So since they're subtracted, we'll be using the division rule. So log of 2y minus 3 divided by y plus 4 is equal to x. Right, so like I was saying earlier, the base here is e. And if we want to convert this into an exponential equation in order to get the y's out, we take the base e, put it to the power x, and equate it to 2y minus 3 over y plus 4. Right, so now the y's are no longer inside the log function, and so we can simplify it. We're going to cross multiply y plus 4 to the power into e to the power of x is equal to 2y minus 3. If I expanded this, I would get e to the power of xy plus 4 e to the power of x is equal to 2y minus 3. Since we're trying to make y the subject, I'm going to combine the y terms. So e to the power of xy minus 2y is equal to minus 3 minus 4 e to the power of x. Factorize, remove the y because we're trying to isolate it. E to the power of x minus 2 is equal to minus 3 minus 4 e to the power of x, and y is equal to minus 3 minus 4 e to the power of x over e to the power of x minus 2. You can leave it like this or put it in a more standard form, which would be take the negative sign out. So you get 3 plus 4 e to the power of x by e to the power of x minus 2, and apply that negative sign to the denominator. So you get 3 plus 4 e to the power of x by 2 minus e to the power of x. This is the last question of this section. It's from 2023's May-June series, paper number 32. So here we have a log equation consisting of natural logs, ln. So I'm just writing it down. Ln of 2x squared minus 3 is equal to twice ln of x minus ln of 2. We have to solve it and give our answer in exact form. So what I'm going to do here is, since we're solving for x, I'm going to first take all the x terms to one side, and then I'm going to simplify it. So ln 2x squared minus 3 minus 2 log x is equal to minus ln of 2 or log of 2. Right, so these are subtracted logs, so we'll be using the division rule to combine them. But before you do that, the 2 over here has to be taken inside the log. So log of 2x squared minus 3 minus log of x squared, the 2 goes inside as the power of x, is equal to minus log of 2. Now I'm going to use the division rule and combine them. So I get log of 2x squared minus 3 by x squared is equal to minus log of 2. Now minus log of 2, I need to take this minus sign inside as well. So it becomes log of 2 to the power of minus 1. Right, so what we have here is a single log on the left and a single log on the right. So we know that if log of m is equal to log of n, then m must be equal to n. So if the logs are equal, then 2x squared minus 3 over x squared is equal to 2 to the power of minus 1. 2 to the power of minus 1 can also be written as 1 by 2. Now we just simplify, so I'm going to just cross multiply 4x squared minus 6 is equal to x squared. So I have taken the x squared up there and the 2 is multiplied here. So I have 3x squared minus 6 is equal to 0. X squared is equal to 6. You can either put it in your calculator or you can do it manually. So this is 6 by 3, which is 2. So x must be plus or minus root 2. Now, as always, you want to go back and see if these two values of x work in the original equation. Now I can see that there's a log x. So log of negative root 2 would give me a math error on my calculator because you can't find the log of a negative number. So the negative root 2 value we are going to discard and we'll just keep x is equal to plus root